of the square root of c over 125. Good. You can stop sharing. Okay, so we know what we have to do. We have log base 5 of the numerator minus log base 5 of the denominator. We are using the quotient rule. This will be replaced by 5 to the third, and we will bring the power in front. Of course, this has to be replaced by c to 1/2, so we can bring the power in front. And that's it. There's nothing else to it. Log base 5 of c minus 3, because log base 5 of 5 is 1. Log base a of a is 1. As long as these numbers are the same, a raised to the first power is a. So please review, always review the problems we did in class before you start anything. It's the best way. Good, very good. Anything else? Next question, anything? Anything else? Okay, so I'm going to start reviewing now. You can ask any question, you can stop me anytime. Okay, so I'm going to start going backwards. I'm going to start with the word problems. Okay. So we have a function that is given to us. Let me open on the page so you can see it. 1 second. Almost there. Clicking, clicking, clicking. Okay. Emily, did you have anything else for us? Anything else we need to review or look at?
Yeah, I have a couple more. Let me.
Oh, yeah. Let's continue with that before we start with this. Of course. I'll stop sharing so you can share. Okay, good. Use properties of logs to condense. Okay, very good. 1/6, 5 natural log applied to x plus 2 minus natural log x, and minus natural log of x squared minus 64. Good. You can stop sharing now. Very good. So remember what we said, we cannot condense if there is a number in front of log. There is no number. If you want, yes, it's -1, but nothing else, and -1. But there is a 5 here. So first I have to put it back where it came from. It came from the power of x plus 2. So that's our first step. So natural log of x plus 2 to the 5th power minus natural log of x squared minus 64. And now 1/6 stays in front. All of them are natural log, so I write natural log. There is plus in front of the first one, so it must come from the numerator. There is minus in front of the other two, so they must come from the denominator. Final step, I have to do something with this. But this is basically the 6th root, because this will be the power 1/6. So then, natural log the 6th root of x plus 2 to the 5th over x squared minus 64. Again, and again and again. You gain a lot of information and skill when you go back and review the problems we did in class first. Very good question, very good problem. So let's analyze the next one. Other questions? Anything else?
I have a question about studying for the tests.
Yes.
How
The
do you
first,
suggest-
the first step is you have to do the problems we did in class, all of them. Multiple times before you say, I got it. I can do this on my own now.
So do you suggest rewatching all of our classes that we had
Yes.
before the test? Okay.
Yes. Yes. We only had 3 actually, because it's such a short chapter. And watch the video when you need it. So if you get stuck or you don't understand the steps here, then watch the video that follows through.
Okay.
So you can
Thank
listen.
you.
Yes, this is what I would do. And then the homework, guaranteed, will not take you more than half an hour. But if you don't do this and you just start homework, it's more difficult. Then you have to look up this and you have to look up this. What does this mean? Where did I see this? But if you redo always the problems we do in class, you'll have 0 difficulty. It doesn't mean that I want my students to ask questions. That's why I'm here, is to communicate and go over problems together. Okay, any questions on this? Is this okay? Do we
Yes, it
understand?
makes more sense.
Perfect. Do we understand all steps?
I do, and I'm gonna go back before the test, and I'm gonna review all of our classes just so I can get a good grade.
Exactly. Okay, good. The next question, it doesn't matter. Right now, if you have questions, let's go over. Everyone would benefit from this. This does not mean that what you study, it replaces your questions. No, no, no. I still hope students have questions so we can go over them in class. Okay, next question. Anyone? Okay then. So let me share my screen then now. And where is my book? Here's my book. I would like to look at this problem. According to the U.S. Census Bureau of the Census, in 2000, I'm taking notes. So this is 86 on 540. In 2000, there were 35.3 million residents of Hispanic origin living in the United States. By 2018, the number had increased to 59.9. So I took notes on those. The exponential growth function is A, basically it's A of t, is 35.3 e to k, which is the growth rate, times t. Describes the US Hispanic population A in millions. So I take notes, of course, millions. And t years after 2000. When I see t years after 2000, I know that the year 2000 represents t equals what? When I'm told t years after 2000, what does that mean? 2000 represents t equals? Emily, I'm afraid that Christy, Imani, and Hunter are not here, so it's just you and me.
I just did this homework today, so I'm not sure if this is right, but is this where you take 2018 minus 2000?
So first of all, the question is, when it says t years after 2000, what does 2000 represent?
0.
Exactly. Okay, Christy is back. Thank you, Christy. Good. So this is extremely important to remember. Also, when we talk about origin or initial or beginning, all these mean time equals 0. So please remember, this is the wording of the problem, and this is very important to understand. We haven't gotten to any questions yet. I wanted to establish, when I'm told t years after 2004, it means 2004 means t equals 0. T years after 2025 means 2025 represents t equals 0. Okay, that's what I wanted to establish for now. Let's move on. Good. Find k. K is this constant in front of t at the power of e, which represents the growth rate. It says correct to 2 decimal places. Okay. So we are given some information, and in part A, we're asked find k. So I cannot put 99% of the cases, I cannot put the name of a year in calculations. So that's why I wanted to make sure that you understand that t equals 0 represents year 2000. What is t for 2018 if t equals 0 represents 2000?
It'll be 18.
Exactly. Awesome. 18 years. Perfect. So when we know that t equals 0 is associated to 35.3 million, what does that mean? It means this. In the model, this is the original amount, initial amount, or beginning. Because they're all associated with t equals 0. So 2000 represents t equals 0. It means that this is the initial value, or the original value, or the beginning. Done. Now, I do have another piece of information here, which is a point. What do I mean by a point? When t is 18, a of t is 59.9. This is the point, an ordered pair. In other words, 18, comma, 59.9, which means when this piece is 59.9, this piece is 18. And that will allow us to solve for k. Because this is known, 59.9. This is known, 35.3. This is a number. T is known, 18. So we have only one variable, that is k. And that's what they're asking us to find first. So 59.9 equals 35.3. E, t is 18, 18k. This is what type of equation? And how do I solve it for k?
You will have to divide 35.3.
Exactly. Clean it up. Thank you, Christy. Thank you. That's exactly what we did. So 59.9 over 35.3 equals e to 18k. That's the first step. So this is an exponential equation. Very important to identify what it is, because if it's logarithmic, I do one thing. If it's exponential, I do something else. If it's quadratic, I do something else. If it's absolute value, I do something else. If it's rational, I do something else. So first, identifying it tells us what are the following steps. Good, excellent. What do I do next? Very good, thank you. what do I do next? Anyone remembers? What is our next step towards solving this for K? Anyone, please? Yes, go ahead, please.
Would it be the natural log?
Yes, because the base is E. It doesn't really matter. But because the base is E, it will be easier if we apply natural log to both sides. We are applying the inverse function to both sides. And that allows us to bring 18K in front. And we know that natural log E is a very nice number, which is
1.
yes, because the base is hidden, but we know it's there. So the answer is 1. So I don't have anything else on the right-hand side but just 18K, because natural log E is 1. The left-hand side, leave it alone as is. Oops, 59.9 over 35.3. Good. And now what I have to do is divide by 18 to get K. So K equals the top. Do not separate it. Don't do anything to it. We put this in the graphing calculator, and they want 2 decimal places. Normally, for K, we use 4 decimal places. Approximation. But that's okay. They want 2 decimal places, that's fine. So we have natural log, and that's 59.9 divided by 35.3, close, and divide by 18. And now press enter. 2 decimal places. So it's 029, which means 03, because this third digit is 5 or more. So K is approximately 0.03. I found K. I have to put it back in the model, right here. And I have everything. I know everything about the function. A0 e to 0.03 t, and it's a function of t. So now we have the model, and we have to write it. So a of t is 35.3 e to 0.03 t. Now they can ask us whatever they want about this. We have the function. Let's see what they want next. Use the resulting model, which we have, to project the Hispanic resident population in 2020. So in part B, they want us to find A of t in 2020. I know I cannot plug this in, but I have to identify what t represents.
It will be 20.
Indeed, 20 years. So all I have to do is find A of 20. As you know, exactly what I'm going to do next, because I'm not lazy, but I don't want to increase the error. So I will put in the function 35.3 and do everything in one step to reduce any possible error. Okay? So this is the function I'm checking, 35.3, correct? E to 0.03x. Perfect. And now they're asking me to plug in 20. Fine. No problem at all. Okay, so I see 64.32 million. Why? Million residents. Why? Because A is given in million. Okay, now moving on. In which year, in other words, when means find the time, t, in which year will the Hispanic resident population reach 70 million, assuming the model still holds? Because this model may change. Who knows? But we assume now in part C that the Hispanic resident population model still holds. When will it reach 70 million? When? Once I have T, I'll add it to 2000 and I'll know exactly which year. So how do I proceed? Anyone would like to help? Hunter, do you want to say anything? Imani, do you want to say anything?
Will you have to put 7 million equal to the equation?
Exactly. So this is A of T. This is A of T. And we want to find T. Very good. So we have 70 equals 35.3 e to 0.03 T. All the same steps. Everything that we just did. All the same steps. So of course we have to clean it up. Of course, we have to apply natural log to both sides because the base is e and makes it much easier on the right-hand side. And this is 0.03 t. And of course, I divide by 0.03. And it's done. This at the top. Don't get confused. This is not natural log of 70 over something else. No, this is like this. Right? Because we applied natural log to both sides as we see them. Okay. All I have to do is just plug it in and see what I get. So natural log of 70 divided by 35.5. 35.3, sorry. Close the parenthesis and divide by 0.03, this number. You can, if you want to get the best answer, you will do second and the previous answer, and you will take the whole thing. We're not going to get the same thing if I put in 0.03. I'm going to show you in a second. So if you want the best approximation, is 23.3 years since 2000. Now, if you just want to do this and divide by 0.03, let's see what we get, how far we are. Same thing, but I'm divided by the approximation. Quite a huge difference. You could say, yeah, but I'm going to round this up. Fine, I agree. It's fine. But it's quite a difference. Because rounding this up gives us 22.82, and using the whole number gives us 23.3. Okay? So it's up to you what you want to write. Approximately 2022, 2023. Because T is 22 or 23. Any questions about exponential growth? This was a problem on exponential growth.